Okay, so hi all, good evening and welcome to the 8th week of TA live sessions for AI KRR. And is my voice audible and is the screen visible? Can anyone
Yes,
confirm?
sir. Yes, sir.
Okay, thanks for confirming. So, yeah, today we'll be discussing some questions related to week 8, um, where we'll be dealing with a bit of first order logic and then we'll gradually move on to RDF and RDFS. Um, So, yeah, without any further delays, let's get started with the questions for today. So, this is the first question. So, the first couple of questions will ask you to, they'll give you a sentence in English in normal day to day conversation language, and we have to select the appropriate first order logic representation of those statements. For example, here you are given the statement as all apples are red, and we have to select which of the following is the correct first order logic representation of this statement. So I'll give you maybe a minute to think about it. Um, which of these do you think?
Option A and D.
Okay, so there's a vote for options A and D. So I'll give you a hint.
Option A and C, sir. Maybe.
No, sir. A, only A. D, no. D will not be the answer.
Okay, so there are a couple of votes for multiple options, out of which A is common, and then there are a few votes for option C, so a few votes for option D. So let's go over the options one by one and see if that makes sense. So the first option says that for all x, if x is an apple, this implies that x is red. Okay, so for anything that can be represented by this variable x, if x happens to be an apple, then we can straight away say that x is also red. So this confirms with our definition, all apples are red. Okay, now let's look at the other options. The second option says that there exists some x such that if x is an apple, which implies that it is red, which means that there are some entities that are apples and hence they are red. But that also means, because this is an existential quantifier and not a universal quantifier, we cannot generalize it to all things that are apples, right? So let's move on to the third option then. Um, Third option, it might seem like it also conveys the exact same thing, but if you look closely, it says that for all x, x is an apple and x is red. So which means that anything that is be represented by this that will be represented by this variable x, that has to be an apple and that has to be red, which is not what this statement is suggesting, right? It's just saying that everything that is an apple is red. And then the last option is again not true for similar reasons, because this uses an existential quantifier, not a universal quantifier. So the correct option would be option A only. Any doubts in this question?
Sir, actually, that doubt is actually, if we look the semantics of the English semantics of the statement, like all apples are red. So if we look at the semantics, that may not be true, sir, because we have something called green apples kind of thing.
Yeah.
But
Huh.
so if we go as per the predicate logic, so all apples are red in the sense, doesn't it convey that if it is apple and it is red?
No. So two things. So I'll address two things you have pointed out. So I'll address them one by one. First thing is, we know that some apples are not red. There are some green apples, but
Yes.
that is something that we know. But if we are asking some logical machinery to think about it, that logical machinery would not be aware of that fact unless we specifically tell that to it. So when we give this statement, all apples are red, and we want to represent it in terms of first order logic, the logical machinery will assume that this is the only piece of information available, and it will try to formulate it in a form that conveys anything that is an apple is supposed to be red. Okay. And then the second point that you told is, for everything that is represented by x, you're saying that apple x and red x should also be true. That is am I
Yes, sir.
interpreting your
Yes.
question correctly?
Yes, sir. Correct, sir.
Okay. So it so there's a slight nuance to it. Um, the way this sentence is structured, it says that all apples are red. Okay. Um,
Okay.
so this, if you look closer into it, this sort of represents an if then condition.
Okay.
If anything is an apple, then it's red. That is how we can expand this statement. But
Okay.
if we expand it in this way, anything is an apple and anything is red, that doesn't translate exactly to the same uh, fact that is conveyed by all apples are red. That is why the third option is incorrect.
Okay, but previously, like we have already discussed this in one of the assignments, there was a statement called all dogs are not cats.
Yeah.
There was one direct answer. That is fine. So that time also I have raised a similar question, sir. And further, there are two options too. All dogs are not cats, and also all cats are not dogs. Both the things, the answer was given.
Yeah.
So,
Maybe
like,
that's
of
because.
course, there is no negation here.
Hmm.
So, something similar to that logic, can we write in other forms of this sentence other than this implication thing?
Um, so the opposite of the statement given to us would be that. Um, so here we are given all apples are red. The opposite would be anything that is red is also an apple, or
Okay,
it
okay.
can be an apple. But then we cannot use an universal quantifier there um, because if we use an universal quantifier, we are saying that anything that is red is also an apple, which is not true. There can be other entities that are red in color. Um,
Oh,
so yeah, it doesn't exactly translate to the same example that we discussed earlier, where all dogs are cats or something like that. Um,
okay.
yeah. So here I think only one option is the correct choice to go ahead with.
So, sir, then can I take granted? So, in future, if I get any question,
Huh.
for example, all roses are red.
Hmm.
So then all cats are dogs.
Yes.
Then if in the sense like in a sentence, if there is all some like subject or object kind of thing and some color or some quality kind of thing, can
Hmm.
I take it granted directly that the option similar to A would be true?
Yes, if the sentence follows a similar structure, we can first of all, if there is an all in the statement, then that's a big hint that we have to use a universal quantifier, right? Because it
No,
would.
that is fine, sir. Universal quantification is fine. That
Uh,
implies, I'm asking. Implies symbol, sir.
yeah, if for example, let's say there is a statement instead of all apples are red, let's say we have something like all candies are sweet.
Okay.
Yeah,
All tigers are cats.
yeah,
All
something
lions
like.
are dogs, kind of thing.
Yeah, so all of them would follow a similar representation to option A.
Okay. So I'm asking any other alternate representation, sir. Can you just write and show that symbolic logic? I'm asking. For the same statement, any other alternative?
I mean, another alternative is just the just another way of restating this implication, right? Where we can write for all x, not of apple x or red of x.
Okay.
Yeah,
Only two ways. Two ways are possible.
two ways that I can think of right now. Uh,
Okay.
but yeah, I would also urge you and others to also think about it. And if I am leaving out or if we are leaving out anyway, so please feel free to point out.
Okay. Okay, sir. Thank you, sir. Go ahead, sir.
Thank you. Okay, then let's move on to the second question then. So this is slight modification to the previous statement that we had. This says that some apples are red and the options remain the same. So which option do you think would be the correct FOL representation of this statement?
So B could be
Option
correct, sir.
option D, sir.
Option D.
That's right. So there are a couple of votes. So from the votes, I can see that there's a confusion between options B and D. Okay, and let's look at, so we can clearly say that options A and C are not correct because they use universal quantifier. This has to use an existential quantifier because we are talking about some apples, not all apples. Now the confusion is whether to use implication or and. Okay, um, now when we are talking about some apples, okay, we are talking about some specific entities that are apples. Okay, we are not generalizing and saying that everything that is an apple is supposed to be red. If we were generalizing, we could use an implication here, but we are talking about the quality of some specific entities, and that's why we have to use an and operator over here, not an implication operator. So we have to say that there exists some entities that can be represented by variable x, where x is an apple and x is also red. Okay, so the correct option here would be option D and not option B.
Okay, okay. So, like, so if some implication, if you are, I mean, if there is an existential quantifier, then so that may not follow the implication, right?
Yes, because in existential quantifier we are talking about some specific elements or some specific entities only, not all entities. We are not generalizing.
But even option B also says about only some apples, no, sir? Like, there
No,
are some apples that are red,
it
kind of thing.
it has an existential quantifier, but the way we read it is that there exists x such that apple x implies red x. So
If I,
which,
there exist some apples, if it is an apple, then it is red.
yeah, but implication means that this always happens, which means that if x is an apple, x has to be red, irrespective of whether we have the universal quantifier or existential quantifier in front of it. This becomes like a rule of law, right? um, but there might be a case that there's, like you said, there are some green apples.
Yes,
So
sir.
although the machine is not aware of that, to keep that possibility open, we have to go with an and operator and not an implication operator, because an implication operator becomes a rule, that whenever it also won't gel in with the existential quantifier, because implication operator is sort of a generalization, as in whenever you have an entity that is an apple, if you use an implication, it has to mean that it has to be red, but it doesn't gel in well with an existential quantifier's use over here.
Yes, sir. Like in continuation to previous discussion, same thing, sir. So if you are taking option D, there is something. So if we, for the time being, if we keep that existential quantifier aside, so we can read something like, if it is an apple, then definitely it is red.
In what context?
And I'm asking, if you are taking option D for
Yes.
temporarily, let us forget about existential quantifier, right? Without existential quantifier, if I am reading, so what does that, what does the sentence gives is, if it is apple, then it is red. I mean, if it is apple and compulsorily it is red, the kind of meaning it is giving, right?
Option B or option D?
Option D, sir.
Option D is saying that something is an apple and something is red. There is no if condition involved there.
Okay. No, generally, like, we are assuming it to be true, no, sir. Like, we are stating that, yes, X is an apple and X is definitely red.
Yes.
Then only this statement will be true, right?
Yes.
So the same confusion, sir. Like, so previously, when I asked about universal quantifier, you told that it may not be exactly the thing. But when we come to existential quantifier, once again, that is creating a little bit confusion.
Because
Using of,
existential quantifier talks about specific entities, universal quantifier talks about all possible entities in the
yeah,
universe of discourse. That's why when we use a universal quantifier, we have to use a generalization. That's why an implication comes into use. Whenever we use an existential quantifier in the framework, that frame in the same format of sentence that is supplied to us here, we are talking about
yes.
specific entities only, and that's why we don't want to generalize, and that's why we use an and operator instead of implication.
Okay, okay. So now I can take granted something like this, sir. Like, as you earlier clarified me. So if there is an all apples are red, all roses are red, then compulsorily we can use implication. If there is some, definitely we can use and. Can I take something like granted like this?
Yes, given
Yes.
that the sentence that we have to convert is following a very similar format to what is given to us. If there is a slight
Okay.
change in the way sentence is framed, this
Okay.
sort of
No, I'm
trick
asking
that
about
we
only the same
formulated
sentences.
is it won't always work. So you have to be careful
Yeah.
of how exactly the sentence has been framed in English.
Okay. For simple sentences, I mean, same sentences like this, these rules follow, right?
Yes.
Okay, sir. Thank you. Go ahead, sir.
Okay, then let's move on to question 3. So you might have come across this relation called a sibling relation in the lecture videos, which basically tells us that sibling x comma y tells that x and y are siblings of each other. Okay. Now we have to select what kind of property does the sibling relation follow, and these are the options that you have to choose from. So which of these do you think would follow? Would be true in case of a sibling relation?
I think one is option B, sir.
That's right. It will be a binary relation because it's involving two people.
And I think option D, I think it can be true.
That's right. Because if x is a sibling of y, y also is a
Why
sibling of
is
x.
also sibling of X?
What about other options?
Actually, no idea about anti-symmetric, sir.
So
Can if
anti-symmetric
you
is something. So symmetric basically says that if A is related to B, then B is also related to A. That is what symmetric relation is. That much is okay, right? Can you hear me?
yes, sir, I can hear, sir.
Okay.
Yes.
So anti-symmetric just has this added condition that if A is related to B and B is related to A, if and only if A and B are the same things. Okay, that is what anti-symmetry means.
Sir, can you give some examples, sir, for anti-symmetric relation in the form of live things, say colors, fruits, kind of thing?
Um, Let me think about it. So this is what so this is an example. Okay,
Sir,
the divisibility relation on the natural numbers is an important example of antisymmetric relation. Okay, um, so what this says is um, only way each of two numbers can be divisible by the other if the two are in fact the same number. 12 is divisible by 4, but 4 is not divisible by 12, right? So something this is exactly the kind of example that I was looking for.
okay, sir.
Right, so a number n is divisible by m if and m is divisible by n if and only if m is equal to n. Okay, that is an example of antisymmetry. You can look for more examples over here
Okay.
in the page. There's another thing that I would like to point out because maybe you might have questions related to that as well, which is irreflexive relations. Okay, so you know
Yes,
what
sir.
reflexive relations are, right? When a is related to itself.
Yes, sir.
Areflexive is just the opposite of that. When there is no such element such that A is related to itself, there is no such A for which A is related to itself, then it is an areflexive relation. Okay. So coming back to the options here, now do you think other options would be true?
Sir, actually, when this kind of questions were asked, I think we should go for English semantics of the word and then decide the answers, right?
I mean, here sibling relation clearly it is equivalent to the semantic meaning of sibling in English. But
Okay.
I would again caution you over here that it's not it will not always be true that um, sibling let's say the word sibling corresponds to the same thing as brothers or sisters in logical reasoning as well, because here we might just use a certain word from English and then assign it a completely different meaning that we assign to the logical machinery. So just be careful about what exactly is being referred to.
But actually, in the lecture, most of the things, I mean, sir was explaining about the family relations. So
Yeah, so
like
in that
a set
context,
of,
you can assume that it's the
uh,
same meaning as the common English meaning.
yeah, yes, sir. But assume that if there is a case,
What kind of case?
Sir, brother of XY. Is it a symmetric relation or not?
What do you think?
Sir,
assume that if
X
there
is
is a
sir,
case,
X is brother of Y. So can
Hmm.
we say that Y is brother of X? It may be or it may not be, na? That Y may be a sister of X.
Yeah, so that's why brother is not symmetric, but sibling is a general term
sibling
which is gender
can be common,
irrespective, right?
right? Irrespective of gender.
So sibling corresponds to both brothers and sisters. Okay, coming back to the options. So do you think it is anti-symmetric?
So if it is symmetric, definitely it shouldn't be anti-symmetric, sir.
Yeah.
Of what I
Oh,
So
yeah.
yeah, it's not anti-symmetric. Also, as per the definition of anti-symmetric, it doesn't make sense. If A is a sibling of B and B is a sibling of A and B have to be the same persons, which doesn't make any sense, right? And by the same logic, sibling is also not a reflexive relation, right? Because saying that a person is a sibling of himself or herself also doesn't make sense. What about transitive relation?
Yeah, it may be.
Maybe, or it is.
Yeah, it is.
It is,
They're
right?
It
gonna,
will be
yeah,
transitive.
yeah,
Yeah.
yeah.
Yeah, it is transitive. So to answer a question in the chat box, it's not asymmetric, Kushagra, but I would just like to point out one thing. I think I missed pointing it out earlier, that just because it is symmetric doesn't mean that it cannot be antisymmetric. Okay, so this rule doesn't always apply. There's a difference between antisymmetric and asymmetric. Something can be symmetric as well as antisymmetric. But yeah, just think about it. But yeah, the correct options over here are binary relation, symmetric relation, transitive relation, and irreflexive relation.
So can you explain ternary relation? Is it the
Ternary relation
three-way?
essentially means that
It's
something that involves three entities.
three, okay.
Yeah, but here we are dealing with two entities
Only
only,
two.
so that's
Yes.
why it's a binary relation.
So ternary means is something like that. If X is sibling of Y, Y is sibling of Z, and Z will X will be sibling of Z. Kind of
No,
that, right?
no, ternary
That is
relation is a
transitive.
That is transitive. Then ternary in the sense.
ternary is something a relation defined between three variables.
That is tertiary also.
I mean, ternary is also a synonym of
We
that.
have an operator like if some condition, so we will have two things. Yes, so that is if it is true, we'll have something, and if it is false, we'll have something. The
Yeah,
ternary operator.
yeah, basically you can think of it as a function and the number of arguments in the
Uh,
function. Okay, if it takes two arguments, it's a binary relation. If it takes three arguments, it's a ternary relation.
okay.
Okay, then um, let's move on to the fourth question now. So the fourth question is, again we are given a certain set of so basically we have to find a representation of the grandfather relation. Okay, again here the grandfather relation is synonymous to the usual meaning of a grandfather in English language. And here we also have to use these different relations given to us. So GF basically represents grandfather, where X is the grandfather of Y. Parent X comma Y represents that X is a parent of Y. Father X comma Y represents X is a father of Y, and child X comma Y represents X is a child of Y. Now among these four options, we have to select which of the option or options are correctly defining the grandfather relation. So I'll let you think over it for a couple of minutes and then we'll discuss the solution. I'm giving you a
Sir,
hint that
is this question is having single answer or multiple answers?
that's what I was about to say. I'll give you a hint that this has multiple correct answers.
Okay, sir. Etc.
Okay, any guesses?
Sir, I think
B and D.
A, A might be correct, sir.
D and D, sir.
Okay, so we have different votes. Let's go over the options. And so, first of all, we'll think of, I mean, we all know what a grandfather relation is, but it basically means that firstly, it represents a relation between a male entity and another person, which may or may not be a male, because we are referring to a grandfather here, not a grandmother. And then there have to be three generations over here. So grandfather would have a child, and that child would be a parent to another child. That is something that we are all agreed upon. Now let's look at the options one by one. So the first option says that for all x, for all y, and for all z, grandfather x comma y is equivalent to the fact that x is a male. Okay, this makes sense because x is supposed to be a grandfather, and x is a parent to z, and z is a parent to y. Now, while this looks like it's making sense, because there is a universal quantifier over here, this actually reads as everything that can be represented by x is a male, and x is a parent of everything that is represented by z, and then z is a parent of everything that is represented by y, which is not exactly true for grandfather relation, right? I mean, it's supposed to be confined to a specific family. We can't say that x is a grandfather of every other person, and that person is a parent of every other person, right? So that's why option A would be incorrect. Coming to option B, now option B says that for all x and y, x is a male. Okay, this is okay as of now. There exists some entity or some person z such that x is a person of z, and that z is a person, z is a parent of another person, which is y. Okay, so now because here we have an existential quantifier for z, we have confined the relation to that specific family. That's why option B would be correct. Okay. um, For similar reasons, option C would be incorrect and option D would be correct, because so here the only abstraction that we are doing over here is we are removing the male x part, because father kind of covers that. Father itself means that x is a male and x is a parent of another person. And like we said in case of option A, option C conveys that everything is a father of Z, and Z is a father of Z is a parent of everything else. That is not exactly what we want to convey. But option D uses an existential quantifier, and that is why the correct options are B and D.
So I have a very basic doubt, maybe
Uh-huh.
for the last for the last one, sir.
Okay,
Uh, we have not used the universal quantifier in the first case.
that's right.
Does it cover the second term as well, sir?
In which
The last one, option D,
okay.
existential or the for Z you have given, no, sir.
Mm-hmm.
So that is for the first term or for the second? It's for the second term as well. Am I right, sir?
So that existential quantifier is applied to
To the first term.
the z to z. No, it's applicable to all of them
Yes, sir. Yes, sir. For all
because
Z. For all Z. Okay. Okay,
yeah.
sir. Okay.
No, there exists z, and that the existential quantifier. Then there is a parenthesis for starting from father up
Uh,
till the end.
yes, sir. That's for all Z. Oh, certain Z. Certain
Certain
Z.
z, yeah, not for all
Yes.
z.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Yeah.
Sir,
Okay.
actually, if you don't mind, my internet got disconnected. Can you explain that option A, sir? Like why it is wrong?
So yeah, option A is incorrect because what it actually is conveying is that anything that is represented by X is a male, and X is a parent of anything that is represented by Z, and Z is a parent of anything that is represented by Y. So if you put it in simple terms, it becomes X is a parent of everything, and Z is in turn a parent of everything. So that is not exactly what grandfather relation is.
Okay, okay, sir. Thank you,
Yeah.
sir.
Okay, then let's move on to the next question. And again, we have a statement. This statement says that all students enroll for courses. Again, we have to select the correct FOL representation of this one.
Maybe B, sir. Not sure, but
Okay, we have a vote for option B, and in the chat, we have a vote for options C and D as well. Let's have a look. So this basically tells us all students enroll for courses. So there are a number of concepts in this statement. First thing is students, second thing is enrolling, and third thing is courses. Okay, and then we have a universal quantifier, and that universal quantifier applies to students, not to courses, right? This is an essential point. It's not like all students enroll for all courses. All students enroll for courses where some courses is implied. Okay, so uh, let's discuss option B first. Option B says that for all x, if x is a student, so I'm discussing this one. For all x, if x is a student, this implies that there exists some entity called y such that y is a course, and x, which represents a student, is enrolled in that course y. Okay, this is perfectly conveying what this statement over here tells us. So option B is correct. Now let's look at y option. Oh, state giveaway y option A is incorrect because the implied operator is not used correctly over here. So this is state giveaway. And then y option C and D are incorrect. Let's have a look at that. This says that for all x, for all y, right? So like I was telling initially, this statement tells us that all students, where all is referring to the students, not the courses, right? So we cannot use a universal quantifier for courses. That's why option C and D are incorrect. So the correct option is option B alone.
sir, actually, if this is the case, then we should check the English semantics of the sentence, right, sir? So we cannot go with the logic alone. So if that is to be happen, then all should be everywhere, right? Uh, uh, all students, all enrolls, all courses kind of thing.
No, see, enroll is a connecting concept that connects students to courses. So this doesn't make sense to apply
Yes, sir.
a
Actually,
quantifier.
that
Let
things,
me complete,
that things
please.
we will be, yes, sir.
Yeah. So it doesn't make sense to apply a quantifier before enroll. As far as students and courses are concerned, because this statement tells us that all students enroll for courses, um, it is very clear that all applies to students at least, that we know. Now we have to check whether it all applies to courses or not. That is the confusion, right? So here it tells us that all students enroll for courses. Because this statement doesn't tell us that all students enroll for all courses, that's why we have to keep that in mind, that there might be a case where all students enroll for all courses, and to give that benefit of doubt, we have to use an existential quantifier here.
Okay. No, sir, that thing we will be knowing at least if we look sometimes at the semantics of the sentence, right, sir? Otherwise, like
What
if
do
you are
you
going with
what what do you
logic
mean by
alone,
the semantic of the sentence? Like, what interpretation of the sentence do you have in
English
mind?
meaning of the sentence.
Sorry.
English meaning of the sentence, sir.
Okay, so what do you think this sentence conveys in normal semantic terms? All students
No, no,
enroll for courses.
no. I understand, sir. Actually, option B is true because practically, if we see, like all students may not enroll for all courses. If you take any B Tech or M Tech, if there is an all the B Tech courses are not enrolled at a time,
Yes.
kind of. So what I'm telling is like while doing with this predicate logic, sometimes I feel that we should also parallelly see with the semantics of the English semantics of the sentence. No, what I feel.
Okay, so so there are two points that I would like to say in answer to your query. One is
Yes,
that
sir.
so when I say that you shouldn't look too deeply into the semantics of English, is because when we supply this sentence to logical machinery, like I've been saying
Yes, sir.
before, it's not necessarily true that uh, student will actually mean a student in English language. Enroll
Yes,
will
sir.
actually
That,
mean an enrolling in English language, and courses will necessarily mean a course in English language.
yes,
What
sir. Yes.
we are confused about here is whether there is an all or some in front of courses, and that I
Okay.
would say does not have much to do with the meaning of the sentence, rather than it is the technicality in which the sentence is constructed.
Okay.
Okay, that's what I interpret it as. But
Okay.
yeah, I might be misinformed as well, so I would
Be-
encourage
yes, sir.
others to share their
Because
views as well.
yes, sir. Yes, sir. You can complete, sir. Then I'll
Yeah, yeah,
ask, sir.
I'm done. Yeah.
Okay. Because enrolls once again, it has used the binary connective.
Hmm.
So that is just the representation, whatever that is given, right?
Yeah.
Whatever that we have interpreted from the sentence that is given to us.
Yes.
So if you're not concerned about the actual semantic meaning while working with the logic, then what's wrong? Like if I write all students, all enrolls, all courses kind of thing.
I mean
English
that's
semantic that is actually wrong, but logical thing if you take that doesn't mind about semantics, right? As you are stating.
yeah. I mean it doesn't mind in the sense that it doesn't concern itself with it. It will take the meaning that we assign to it.
Okay. Okay, sir. Okay. Got it, sir.
Yeah. So yeah, if yeah, I mean yeah, the viewpoint that I was conveying is what I have interpreted it as. But yeah, if you feel that taking into account the construction of the semantic of the English sentence is helpful, then yeah, there's no harm in keeping that in mind. But just be cautious that yeah, a logical machinery will take to be true whatever we tell it to be true. It won't know the actual meaning of the sentence.
Okay. Okay, sir.
Okay, so let's move on to the next question then. Again, we are given a sentence, and this tells us that squares are rectangles and rectangles are quadrilaterals. So, which option do you think would be correct? Any guesses?
Option C, D.
A and D, sir.
Okay, um, so option A uses implication without correct use of parentheses. So notice that there is an implication between squares and rectangles, and there's an implication between rectangle and square, and there's no clear demarcation. So the first option A is not properly constructed, so A shouldn't be correct. Option B says that um, if x is a square, then x is a rectangle, and this together implies that x is a quadrilateral, which is not exactly what we want to convey. We want to convey two things in the sentence given to us. One part is that anything that is a square is a rectangle, and the second part is anything that is a rectangle is a quadrilateral. Okay, so by the same logic, C is also not correct. Um, Option D is correct because here we are conveying two separate things in two separate parentheses. The first parenthesis conveys that anything that is a square is a rectangle, and the second parenthesis conveys that anything that is a rectangle is a quadrilateral. And then option E is just a restatement of option D by using an extra universal quantifier. We could have used a single quantifier, but here option E uses two quantifiers, but it conveys the same thing that we want to convey. So the correct options are D and E. Okay. Any questions there?
Sir, not exactly from this question. This is very quite clear. Sir, one question is when we are talking about relations, previously we have worked with the question, right? Binary or siblings is binary relation or not kind.
Yeah.
Binary. Relations.
Hmm.
So, like a sibling, if we take the English meaning, that is fine. We can easily interpret that whether this is an which kind of relation.
Hmm.
So assume that I have a statement like
Okay.
red of x comma y,
Okay.
red
Huh.
of x comma y.
Yes.
So if this kind of question is given, how to interpret the relation, sir? What could be the kind of relation?
Because red x comma y has two entities in it, x and y, so it should be a binary
Yes.
relation.
So what about how to interpret whether this is an symmetric or anti-symmetric kind of thing, sir?
Then you will need more information on what exactly that relation means. That has to be supplied in the question.
Okay. So if there is some unknown, if there is a new word which is not actually matching with the English semantics, then we should need other information to interpret the answer, right?
Yes, yes, that is true.
Okay, sir. Thank you, sir.
Okay, then let's move on to the next question. So, okay, now we are done with the examples of converting English sentences to FOL. We'll slightly move on to a property which is monotonicity. Okay, so consider a domain, consider an example. Okay, there's a non-empty domain that contains people, dates, and numbers. Okay, and in this domain, every person has a birth date. Okay, a person's age in years at any given point of time is the difference between the current year and the birth year. And then a person whose age is more than 12 and less than 20 is called a teenager. And the current date is updated at the stroke of midnight. Okay, so can we say that this domain uh, follows the monotonic property of first order logic? So I'll just give a reminder of what a monotonic property is. So basically, when you keep adding new facts to the to your knowledge base, if addition of any new fact at any point of time later down the line does not negate the previously derived facts, then we can say that the monotonic property is maintained. Okay, now given that, which of these options do you think would be correct?
Sir, once again, sir, can you just tell the monotonicity meaning?
So monotonic property basically says that, let's say you have some facts in a knowledge base. Okay, you use some rules of inference to derive some new facts. Okay, so you had some old facts, you derived some new facts. Now at a later point of time down the line, you derived some new facts, even new facts, and if those even new facts do not disprove the previously derived facts, then the monotonic property is maintained. Basically, it means that addition of new information to the knowledge base should not negate the previously proved information.
Okay, 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 sir, got it.
Yes. So focus on the fact that this domain has something called the birth date, and then the age of a person is calculated as a difference of the current year and birth year, and the date is updated at every midnight. So at a later point of time, a person's age is supposed to change. Will that change some derived facts later down the line?
Violates monotonic property.
Sorry?
B, sir,
B, that's right. It violates the monotonic property,
because
which is
every age will vary.
exactly. So let's say we classify a person as being a teenager, and then once that person crosses the age of 20, then the previously derived fact that the person is a teenager becomes false, right? And that is why this domain does not follow the monotonic property, and for the same reason, it also cannot be modeled in first order logic. So the correct options are A and B. Okay. Any doubts there?
Sir, domain of interest is empty. What does it?
Domain is empty means that there are no instances in. So for example, let's say there is a domain called fruits, and inside there are elements like orange, apple, guava, and so on and so forth. If there is a particular domain that does not have anything inside it, that's an empty domain.
So then there exists y p of y. Is it true if the domain of interest is empty?
Can you come again? There exists.
There exists y p of y. Is it
Okay.
true or false if the domain of interest is empty?
What does P of y refer to? I don't know. Can you give some
So
more
I don't
context to it?
know. So the domain of interest is empty, na? So for that only there exists y p of y will be false or true.
Okay. Where did you find this question?
So somewhere I got.
Sorry.
So somewhere I have seen that.
Okay. Is it in one of the practice assignments? Then maybe we can have a look.
Practice no sir. So someone asking me that.
Okay. Um, it's a bit confusing for me.
So domain of interest means that means the domain is phi. So is there any meaning P of y is true?
I mean, so
Something.
basically, there exists y. P of y refers to the fact that there exists some entities y such that p of y is true. Now,
Yeah.
what p of y refers to, whether there are some entities like y, x, y, or z in the domain of interest, that is something that I need a bit more context on to answer it correctly. But based on the information that you are giving me as of now, it does seem like if the domain itself is empty, then yeah, it doesn't make sense for, because y wouldn't exist in that case if the domain is empty. But I would need some further information to correctly interpret the question and then answer, refine my answer if required.
Okay, sir.
Sir,
Okay.
actually, knowledge base, can it be considered as a domain of interest?
um Knowledge base, I mean, can be, I think, yes.
Not always.
I was trying to think of when it cannot be, but yeah, as of now, I can't seem to find an example. Um,
Okay, sir.
yeah, I'll have to think more about it.
Okay, sir.
So one more doubt. If empty domain is existing, it means what? Actually, when that scenario can be seen?
Basically, you can think of it as a set, right? There can be empty sets in existence. So an empty domain is basically like analogous to an empty set.
Okay. So, say somebody asked if some facts are being added,
Hmm.
whether that will become a non-empty domain, then
Yeah, if new facts are getting added to a previously empty domain, it will become non-empty later on.
okay. So there are possibilities of empty domains
Yeah, yeah. Because see,
in
domain
FOL,
is,
first
uh,
order logic.
yeah. So
That
domain
is
is some concept that we come up with, right?
okay.
There is one thing that is universal domain that includes everything and anything and everything under the sun, and then there are further subdivisions of concepts. Which, for example, let's say the example that I was giving earlier. Let's say there is a superset of fruits. Within fruits, there are fruits. There is a set of fruits that are found in India. Then there are a set of fruits that are found in, let's say, Africa. Um, and let's say we were not having any information of the fruits available in Africa before, so that set was initially empty, but once new facts get added, we can fill in that set as well, and then that becomes non-empty.
Hmm. Yes.
Okay, so let's move on to the next question then. The eighth question gives us a knowledge base. Okay, and this knowledge base tells us that for all x and for all y, p of x comma y and q of x, this together implies r of x comma y. Okay, and the set of individuals that we want to operate on is just two individuals, a and b. Which of the following interpretations a, b, c, and d satisfy the knowledge base? Okay, so I'll give you a hint. The easiest way to do it is try to construct a truth table for this implication first of all. Okay, and then see, once you supply these values a, b, and a or b to this x and y, which of in which of those cases in the truth table would the total implication would be true. So
Sir, actually, if we take any statement P of A, B, how to read that? A is P of B. Can I read like that?
sorry, can you come again? If p of a comma b,
Actually, if we look at option A, the first part is P of A comma B. It
yes,
is written, right?
yes,
So if it is written like that, can I read A is P of B kind of thing?
Yeah, you can.
So A is P of B, Q is A, R is P of B. Something like that.
A is Q.
A is Q and R is A is R of B.
Yeah.
Okay. Okay.
Okay, so let me give you one hint with respect to how you can break this down. So just give me a minute. So this is what we are given, okay? And so if we think about it, there are two parts to it. Oops, sorry about that. First is this part, and then there is this part, and then there is the whole thing together. Okay, so if we represent this by A, sorry, let's not use A, let's use something called, okay, what can we, okay, let it be. So this is first part, this is second part. So if you have to frame a truth table, the two parts would be looking something like this. This would be one part, and then this would be another part, and then there will be the whole thing over here which I'm not writing. Okay, it's the same thing as what is given in the knowledge base, this whole thing. And now uh, basically you can assign cases true true, true false, false true, and false false. Okay, and then in what case, what would be the
Only
entry over here?
second case the answer is false. Rest of the cases it is true, right?
Yeah, that's right.
So negation of R of A comma B.
So whenever that is true,
Only in that case,
the whole thing will
yes,
be false, right?
yes, sir.
And all other things it will be true.
Yes.
So that is what is actually the answer we want to arrive at. Okay, so there are four cases corresponding to the four possible ways in which we can assign truth values to these two parts of the knowledge base given to us, fact and the knowledge base given to us. And if we look at each of the options one by one, the first option uh, is P of A comma B, Q of A, and R of A comma B. This would lead to the whole thing being true because of cases 1, 3, and 4. Okay, because the first part would be true because of P of A comma B and Q of A. R A comma B will lead to this being true, and because both of them are true, the whole thing will also be true. Similarly, for the third and last option as well, because of cases 3 and 4 and case 3 respectively, the whole thing will be true. Only when we have this not of R A comma B, the whole thing will evaluate to false. So the interpretations that satisfy the above knowledge base are A, C, and D, and the only one that doesn't satisfy is option B. Okay.
Actually, this seems to be a direct question, but they have given in bit confusing way.
Yeah.
Okay.
Yeah, but good that yeah. Sometimes we do get questions in the simple questions, but asked in a bit of confusing manner. But good that you all caught it. So yeah. Shall we move on to the next question then?
Yes, sir.
Okay. So to answer the query in the chat box, Kushagra, I am not aware of that, and I think it's better if you ask this question to the NPTEL team directly, because they would be more in touch with the logistics of the course and the exams. Okay, coming back to the questions. So again, here we are given a statement. Okay, the statement is that the 2021 World Championship match between Nepo and Carlsen, when Nepo and Carlsen are two entities representing two people, was held in Dubai. Okay, and now we have to treat these symbols Nepo, Carlsen 2021, Dubai, and World Championship Match 21 or WCM 21 as constant, and anything else as predicates. Okay, and now we have to select the representation that most closely resembles a semantic graph corresponding to this sentence. Okay, now forget about the first order logic thing that we were thinking about. Here we are talking about a different kind of representation, which is the semantic graph representation. So which of these do you think would convey the information as given in the sentence to the most amount of precision possible? All of these do convey the information given in the sentence, all of these options do, but which of these is the most precisely conveying option? You have to select that one.
Option A.
Okay, option A looks like it might convey, but then does option A tell us anything about whether Nepo or Carlsen are players in the championship match, or what exactly is the year of the championship match, or what is the location of the championship match?
B, sir.
That's right. B is the option that conveys the information in the most precise manner. It has a predicate for all the information, all the concepts available in the statement. So first it says that WCM21 is a match. Then it says that Nepo is a player who is playing in this world championship. Then Carlsen is also a player playing in this championship. Then it says that the championship is being held in 2021, and then it is held in the city of Dubai. And all of these are connected by AND operators. All the other options have some level of abstraction. That is, they are not being exactly precise in conveying. That is why the correct option is option B. Okay. Shall we move on to the next question then?
Yes, sir.
Okay. So now we are entering the domain of or the topic of RDF for RDFS. So this is kind of a recall based question. Here we have to say the elements used by an RDF or RDFS to model a domain are which of the following? So based on the lecture videos, which of them do you think would be the correct options?
Properties, resources, C and D.
So just a reminder that RDF refers to a resource description framework. Okay, you can find these slides in the Swayam portal. And if you recall, there are three most important things in RDF: resources, properties, and statements. Right? So those are the three things that we need to model a domain in RDF or RDFS. So the correct options would be properties, resources, and statements. Okay, kind of straightforward question, recall based. Let's move on to the next one. So here you are given a particular okay, I won't say what it is because it might give away the answer, but you are given something. Okay, here you have colon Rang, colon poet, and then colon Amir Khusro. You might recall this example from the lecture in the context of RDFS itself. Now we have to identify whether it is a triple, whether it is a statement, whether it follows the turtle format, and whether it is an edge in the semantic graph.
Option A.
Option A is true, it is a triple. What about the other options?
Option C.
Option C is also true, it is also an edge in the semantic graph.
Option B, sir.
Option B is also true. What about option D? So turns out option D is also true. So all four options are correct in this case. So I'll just give a hint of what exactly is this conveying. So this says that um, Rung poet or Rang poet Amir Khusro. Okay, and you can think of Rang as an element of some set S. Let's say S corresponds to songs. And then Amir Khusro, I'm not writing the full thing. This again is an element in a set of poets. Notice that here we are denoting the set with a capital letter, and the connection is represented by a small letter, okay, lowercase letter. So the edge connecting these two is what will we call poet. Okay, so the song Run is written by this poet called Amir Khusro, and it is connected by this edge represented by small lowercase poet. That is what, oops, I think I didn't share my screen, but you can have a look at it now. So this is what essentially this statement represents. Okay, and if I have to give you some more intuition of what this exactly is, yeah, another example could be something like this: Rang, genre, Sufi. So Sufi is another, let's say, set, and then Rang is another set element in the set of songs. Sufi is another element in a set of something else, let's say, and then genre is an edge connecting Rang and Sufi. Okay. So any doubts there? Should we move on to the next question?
Yes.
Okay.
Hello, sir.
Yeah.
Yes, sir. I'm attending from this is first class, sir, my class.
Okay.
Then you are explaining from options questions, no, sir.
Sorry.
You are explaining from choice questions, no, sir.
Yeah, today we are discussing questions corresponding to week 8. If this is your
Yes.
first class, the previous week's recordings are available on the Swayam portal and you can access it there.
Okay, sir. You have any group, sir?
No, there is no group as such, but you can refer to the discussion forum on the Swayam portal. There you will find many people posting their queries and their queries getting answered as well.
Okay, sir. Sir, I have some doubt, one doubt, sir.
Okay.
Sir, I want to write in the 2027 GTK, sir.
Your voice is breaking. Can you maybe use a like bring the microphone closer to you?
Yes, sir.
Yeah.
Sir, I want to write in 2027 get exam.
Okay.
Side to any guidance, then plan how to study. All.
Okay, this is a bit off topic. So let's complete the session for today and then maybe I'll come back to your query. Is that okay?
Okay, sir. Thank you, sir.
Yeah, and you can refer to the link that Kushagra has shared in the chat box for the recordings. Thanks for that, Kushagra.
Okay, sir. Thank you, sir.
Okay, so coming to the next question. So question 12 tells us that an RDF or RDFS document is available in the turtle format, and it is given over here. And yeah, just note that RDF document is case sensitive, so we should pay attention to the lower and upper case. And when we treat this document as a knowledge base, what are the facts that we can infer from it? So given this whole screenshot over here that represents a turtle format RDF document, what are the facts that we can infer from it? So which of these options do you think would be correct? So remember the example that I showed you in the previous question about Rang poet and Amir Khusro.
A, B,
Sir, I think option C is directly given, right? Poet, RDF, RDF property.
Yeah, exactly. It's right there.
Yeah, poet, RDF is type and RDF is property.
Yeah. So options A and B. So C is correct definitely, like Mr. Shyam Sundar said. And then options A and B are also correct, right? Because of the example that we just discussed a while back, right? Rang is an instance of the set or song, which is called song. A song is a class over here in turtle format, and then Amir Khosrow is an instance of poet, and then poet is a property or an edge connecting those two. Now, about the last option, Rang is an instance of RDFS resource. So if you recall the lecture videos, you will notice that anything and everything um, in an RDF data model, everything is a resource and everything is an instance of RDFS resource. Okay, so by this logic, Rung is also an instance of RDFS resource.
Then all options are correct.
Yes, exactly. All are correct options. Okay. So, yeah. So that actually brings us to an end of the questions I have for today. If there is anything pressing that you would like to discuss, you can let me know. Otherwise, we can end the session for today, and I'll get to the other queries that Umesh had asked.
Sir, I have a doubt from the previous week assignment.
Okay.
So question number 17, sir.
From week 7.
Yes, sir.
In the graded assignment.
Yes, sir.
Which question is it?
Sir, question number 17, I think.
Okay.
Open only.
Which of the following are true in SWI prologue?
Sir, 17.
17. Okay.
Yes.
Okay, written it.
Yes, sir.
Oh no, it's different. This other thing.
Sir, how A7, A15 answer?
WME 302. 302 is what? Applicant name is Amy, gender is female, and age is 30. Okay, let's have a look. Name is Amy, gender is female. What were the other things? Age is 30. Okay, so the first attribute is the name. Okay, that name is available in A7 node. Okay,
Sir, A8 also, no? So name is also present in A8. And
Mm,
gender is female, na? So
yeah, but the reason I think, hmm,
why not A8, A15, why A7, A15?
that's right. So one thing that I can think of is if A15 is there, A8 is there by default. But then if we are already including A15, that includes the name. There was
But
no
sir, there
need
is
of,
no path from A7 to A15, no?
yeah. There doesn't always have to be a path for between all the alpha nodes.
That
But
is the
what I
difference.
am confused about is if A15 is already included, there was no point of including A7 because it
A7,
already
yeah. A8
covers.
is already there.
Yeah, A8 is already covered there. So
And for applicant, we can take also A3.
yeah, I mean A3 is also covered by default when we are covering A15.
A15.
Have you asked this query in the discussion forum?
No, sir.
Yeah, I would encourage you to ask this and point this out to Bhaskaran sir. Yeah, I am also not sure why A7 is there.
And also, why two times he has written A7, A15 and A15, A7? Why two times written, sir?
That is because people might have written it in different orders, right? So just to make sure that we award the quiz awards the same marks to whatever order you mention it in. That's why he has mentioned it twice.
That is the order. But why A7, A15? I think A8 and A15 will be the answer.
Yeah, I mean, as per my understanding, only A15 should suffice. But then,
A15 also correct. Only A15.
but yeah, I would
Yes, sir.
encourage you.
Actually, initially I was also thinking the same, sir. Thinking that only I have wrote something like this. So A3, A8, and A15,
Hmm.
so that all things will be covered.
Hmm.
But finally, my answer turned to be wrong.
Yeah. So
Also,
for
also
sure,
both the
A3.
same, sir. A3, A8, A15.
Yeah, so one thing is that for sure when you mention A15, you don't need to mention A8 and A3 because they are all by default covered when you are going in A15. But why A7 is there is what I am not convinced by. So I would encourage you ask this in the discussion forum and point this out.
Okay, sir. I will put it in the discussion forum.
Yes. Anything else? Okay, if not, then I'll stop the recording and then I'll get back to the query that Umesh had asked.